Welcome to Space Startup News Live. I do this live stream every week at the same time. So thank you if you're watching live. And if you're rewatching later, thank you for watching. So I'm going to go over the two videos, two big videos I did this week. I also do a midweek news roundup. And I did this live stream. So I did a video on Neumann drive. So we'll bring that up. Here it is. Put myself in the corner. It's called Goodbye Xenon, Hello Cheap Metal, Why Neumann Drive Could Dominate Space Propulsion. And this is not actually the first video I've done on metal propulsion drive. I did a video in 2024 on MagDrive UK, which has a similar concept. But basically the idea is to use fuel as a propellant. Some people corrected me for saying fuel, because you're not actually burning anything, it's just using it for propulsion. So basically you use an arc device. You can see it on the right here. It just creates a very, very strong spark, which ionizes the metal, turns it into a plasma, and the plasma is then ejected from the end of the spacecraft to provide thrust. So that's it in a nutshell. It's a very, very simple concept. And you can actually see in this, on the left-hand side, this is the CubeSat form factor. And in the middle, you can actually see the metal rod, and where the hole is, that's where the cathode, the cathodic arc thruster is. And the spark is created there, and the plasma is just ejected. So it's a very simple concept, but it has quite a few advantages. One is, first of all, it's solid state. There's no moving parts. It's very simple to manufacture. The propellant is just metal, so it's safe to touch, to handle. It's non-toxic. It doesn't change phase. It doesn't change into a liquid or a gas. And there's quite a lot of it in space as it happens. So here is the team, and the guy sitting down is the chief scientist, Dr. Neumann, or Neumann, as some people said. That's how you pronounce it. So let's have a look at how it works. Very simply, it's you use solar panels to generate electricity. You store that electricity in a capacitor bank, and then you, when you fire, all the energy stored is then produces a very sharp pulse, something like 200 microseconds or millionths of a second, and that's hot enough to turn the metal into plasma, and then the plasma is expelled, generating thrust. It's that simple. And we have, this is from Neumann Drive, Neumann Space. These are the drive units. So you've got the CubeSat, then you've got the three of them clustered together, and then there's something called the Platypus, which is like a very good name, and lots of them just all chained together, because as Neumann say, they're pretty simple to make these. There's no moving parts, and so it's quite easy. And here's from the website is an example of the spark. You can see from the thruster, you can see all the sparks moving in all directions, and those sparks then hit the metal. They have a graphic on the website, so you see the arc triggering here. Then you have the initial cathode spots, and then you have the end of the pulse, and all these little circles here are where the spark hits, the arc hits the metal and generates plasma. And if you look, this is again from the website. So you can see here's the periodic table. On the right side in blue, you have the inert gases that are used in ion thrusters. So typically it would be xenon and krypton. Xenon because it's heavier, but it's now quite expensive, so people are using krypton. For instance, Starlink uses krypton now. But you're very, very limited to what you can use, and these gases are quite expensive. So if you use metal, you can see all those other these other colors. That you can use all of those metals, and it's not just metals. You can use alloys as well, and you can even use things like graphite, because it conducts electricity. So anything that conducts electricity works. there are a few exceptions. There are some low metals with low melting temperatures, such as like tin, lithium, gallium, and so on. But other than that, any metal or alloy will work. The key thing, it has to be able to conduct electricity. And we have here a range of their drives. So you can see you've got there's like 4 different kinds they can use at the moment. They say they're very easy to manufacture, which is great. And here we have the pros and cons. So metal pulsed arc drive pros and cons. So low cost, non-toxic, cheap, very simple design. You don't need grids. And another thing you don't need is neutralizers. The problem with ion drives is they build up a charge. So you have to compensate for that. Otherwise, your spacecraft will become charged, which would not be good. You'd get short circuits and so on. So they have to add a neutralizer. So basically, ion drive shoots out positive charge ions, and a neutralizer has electrons on the side, and it shoots the electrons into the drive. So you neutralize the exhaust gases or the ions, and that way you don't build up a charge on your spacecraft. In the case of the metal arc drives, the pulsed arc thrusters, that doesn't happen because the plasma contains both positive and negative particles. So they call it quasi-neutral. They're all in a stream, but they cancel each other out more or less. So you don't need a neutralizer. So it's less mass, less complexity, and more power for the arc thruster rather than the other systems. So that's an advantage over ion thrusters. The disadvantage is it's pretty low thrust, as in even less than an ion thruster, maybe something like 50 millinewtons. So a 50 millinewtons, maybe up to 100 millinewtons. So like a tenth of a Newton thrust, if you're lucky. So very low thrust, and I guess cathode erodes over time. And the efficiency, if I just move myself out of the corner, lower efficiency, 10 to 12.5% versus gridded iron on ion thrusters, which is 50%. So you've got an efficiency issue, you've got a thrust issue, but basically it has lots of advantages. So that is the pulsed arc thruster, and this is Neumann Drive the video is on, but of course it's not the only company. Mag Drive in the UK is also working on this technology. So yes, that is the Neumann Drive from Neumann Space. So let's see what people had to say about this. There's plenty of comments. So we have Charles Blythefield saying, "Brilliant system. I hope they get the validation checks and grow, because this is the kind of tech we need if space is to be commercialized. Maybe there's a killer app in satellite that gather space junk, because the unregulated things happen now, especially Starlink. Greatly increase the risk of Kessler syndrome, which would be catastrophic for humanity." So Kessler syndrome is where one satellite or piece of debris hits another, then you get a lot of smaller pieces, and you get this chain reaction as those pieces then hit others, which then hit others, and before long the whole of space is completely unusable. So that's the Kessler syndrome, and we are moving in that direction because of all the junk that's already there and is continuing to increase, particularly with some Chinese rockets. The second stage just stays in space. They don't have the fuel to bring it back to Earth, and doing that would reduce mass anyway. So it just stays there in space. Consider there's another 10 Chinese mega constellations about to be launched. The amount of debris will just keep increasing. So that's an issue. But my next video kind of addresses that a bit. So anyway, Wingsley saying, "This is fascinating and very informative, but it leaves me with more questions than answers. How does this drive differ from what is generally known as an ion drive?" It's very similar, except you get in a plasma rather than ions, so you don't need a neutralizer. It can use most of the elements in the periodic table, anything that conducts electricity, as opposed to the inert gases. But they're kind of similar in concept. How does this drive differ from Vasimir? That's a different concept in that it uses radio frequency waves. And also that's been around for a very long time, but I don't think it's gone into production or anything. So I'm not sure that's going anywhere, Vasimir. How does this differ from nuclear electric propulsion? So I'll talk about that more in my next video. Is there a video? So the next video I'm going to talk about in the live stream. Is there a plan to combine this technology with other propulsion technologies mentioned above? Yes, my next video kind of covers that. Can a drive like this be used to send manned spacecraft to interplanetary destinations such as Mars? This technology is really not good for manned exploration because of the very low thrust. Very low thrust means the missions take a long time. And if you're traveling through deep space to Mars, you want to avoid long transit times because you expose the crew to more radiation. So I think this is really only for cargo. For cargo, I think it works, but definitely not for crew, I don't think. There are better alternative propulsion systems you'd use for crew. And can a drive like this be used in cislunar space to provide propulsion to a space tug for conveying shipments of personnel or cargo from Earth orbit to Luna? Yes, for cargo. Yes, it would be perfect for cislunar transport to for supplies to the moon, around the moon, but you'd need more thrust. If I just move myself out of the way for a moment. So we have Richard Burden saying, pair it with a nuclear reactor and you've got a series spacecraft. Yes. And Kay Krolik saying, perfect propulsion for mining drones due in refinery. They can get new metal rods for propulsion. I agree. Great for consuming dead satellites or metallic asteroids and turning them into propulsion. Yes, so a lot of these things I'm going to address in my next video that I did this week that I'm going to talk about. But yeah, they would make perfect like mining drones, propulsion for mining drones, especially on metal asteroids. You have all the metal there, you're mining it, so some of it can be used for the drive. So yeah, it makes a lot of sense. So I think we have another set of slides here. So no valves, no tanks, and no moving parts. Perfect for satellites. Yes, this is the advantage. Marty's saying, every time I drive past Neumann space, I want to drop in and geek out. I better not, though. Yeah. I mean, they're in Adelaide. They're quite near the centre. So, yeah. I don't know if they have open days where you can go and meet the team. But, yeah, I mean, it's a great piece of technology. And it has flight heritage, which I've not mentioned. But they've flown in space already. In fact, with the SpaceX Transporter Twilight mission, which only flew about last week, they had a satellite on that mission. And I think that was a small sat, so it's like a bigger form factor for them. So yeah, they have a vehicle in space right now. So they're doing great. And Ice Rain is saying, the issue is the low theoretical exhaust velocity. Well, actually, it has very high exhaust velocity. Something like 10 kilometers per second, 10 to 30 kilometers per second. And that's why it's so fuel efficient, is because of the high exhaust velocity. Yes, it's high, colored to current alternatives, but the theoretical maximum still has the lighter isotope as the best fuel for Delta V. This is why magnesium, which is lightweight, is their best option. Yeah, magnesium is 3,000 seconds. Obviously, so basically, the lighter the element, the higher the fuel efficiency, but the lower the thrust. So if you use titanium, for instance, you get more thrust, but half the fuel efficiency. So you've got these trade-offs. And so also he's saying thrust is generally easy to achieve, but exhaust velocity comes from hard limitations and mass of physics. So this is great for high exhaust velocity. And especially if you do things at scale, having a high exhaust velocity makes everything a lot cheaper. When you move millions of tons of material, it really adds up. The other benefit is that for space mining, hydrogen is actually pretty rare. It exists in ices beyond the ice line, whereas heavy elements like metals are everywhere and can be mined everywhere. The moon itself is a giant ball of oxygen, aluminium, silicon, and iron. So if you can use aluminium as a high exhaust velocity fuel, pretty useful. While, yeah, aluminium has 2000 seconds specific impulse. It's very fuel efficient, and like you said, it's everywhere. In fact, in our low Earth orbit, it's everywhere as well. So, and of course, you've got the M-type asteroids. So you're going to find metal everywhere. So you're going to find propellant for this drive everywhere. And Christian is saying, with that metal powder fuel, what is pressure and temperature? Was that system going to run on solar alone? Will it have enough power? So, yeah, the thrust kind of scales with power levels. The more power you can put into the arc thruster, the better the drive is. So solar doesn't give you a lot of power. Maybe you're talking about a couple of kilowatts. With the K2 space satellite bus, you can probably get to 20 kilowatts. And in March, they will be launching their mega class with 2 twin 10 kilowatt solar arrays powering a 20 kilowatt ion thruster. So you could get a bit of thrust from that, but realistically, for high power levels, you're going to need a nuclear reactor. I don't see any way around that. And your 20 downrange is saying, no telling how powerful this can get with unlimited electricity, like from 0 Point Energy. So many great ideas have come and gone over lack of electricity. My big question, what size will one of these need to be to provide 1 G of continuous thrust? I'm getting expanse vibes from this one. It's going to have to be very big. The amount of thrust you get from this is tiny in terms of like 50, 100 millinewtons. So unless you're going to put a huge amount of power into it, even getting up to 1 Newton is going to be difficult. And we have a reply here from Dave Etchells saying, replying to someone else, but he's saying, leaving out the viewer's thoughts on 0 Point Energy, the thruster itself makes a lot of sense to me. A very energetic, very short duration pulse would vaporize a small amount of the fuel while producing very high plasma temperatures, which would equate to very high exhaust velocities and thus very high specific impulse. Yes, that's how it works. You get very high exit velocity, which means very high specific impulse. I think the main problem would be to prevent erosion of the reaction chamber and or depositation of the metal on the chamber walls or nozzle. Assuming they solve these problems, this looks like a great and more practical replacement for ion thrusters. So there are ways of directing the plasma using magnetic nozzles, which MagDrive is doing. Magnetic nozzle is just a magnetic field, and it just basically conducts the stream away from the spacecraft and funnels it. Also heats it up as well. And so MagDrive is doing that, and I talk about that in the next section using magnetic nozzles, which have a lot of advantages. So let's move on to, there's one more slide. So Fred Pauling saying, it sounds like Neumann Space have done their homework and made some well thought out trade-offs. It certainly seems attractive to eliminate fluids and minimize volume for small sats. I hope they do well. So another big advantage is it's very simple. These drives are very simple to put together. There's no moving parts. There's no tanks. There's no pressurized, tanks or valves or pipes. You don't need to do cryogenic fuel management. There's no pressure in the system. It's just a very, very simple device that you can mass manufacture and you just handle easily. It comes fully fueled because you put the metal rod inside. It's non-toxic, it's safe to handle, and it's very easy to integrate into a satellite. It's just plug and play. So it's very simple system. Sirius Burn is saying, very cool, but what's the novelty? Pulse plasma thrusters are around for decades. Metals are also known for propulsion. mainly on ion drives. Yes, I know, like indium and not so sexy mercury. Well, those are kind of like toxic metals. You don't want to use them. And ion drives are different in that you need you need to use a magnetic field, and you only get positive ions, so you have to use a neutralizer. So more complexity and yeah, so it's a different system. It works on a slightly different basis and not as simple to put together as this metal drive. And Dave in Vegas is saying, I think the novelty is the near plug-and-play modularity of an off-the-shelf propulsion system. Yeah, you can just mass-produce these, put them on the shelves. They're fine for years later, and very simple to operate and handle. And Q Daniel 97 is saying the novelty is not only using and having to store a liquid or gaseous propellant, and an expensive and or toxic one too. Mercury, indium, and cesium are all pretty nasty and expensive, and were all used in designs that required them to be in liquid phase. Yes, and of course xenon also got very expensive as well, so that's why people switched to krypton. And Pat Kelly is saying, sounds like a possibility as attitude control for larger satellites, infrequent use, reliable, simple, high efficiency. Gotta love Australian humour, name for multi-nozzle system, Platypus. I spent 2 years at Narungga, so the Woomera rocket range, and Adelaide are familiar territory. And David Jong is saying, I hope we see nuclear propulsion in our lifetimes. So exciting. Well, it's will be on the Artemis base camp, and that will be by 2030, according to Jared Isaacman. And he wants to push the schedule left, and he wants to be in front of the schedule. So there's definitely some micro nuclear reactors. There's companies that are producing them already. They have models, so they just have to adapt them for the moon. And we have certain companies like Antares that already have lunar designs for micronuclear reactors. So I think with the new NASA administrators, there's going to be a big push towards nuclear reactors for fission surface power on the moon, but also in space as well for space propulsion. So I think we're going to see a big push, which would be great. And then we have SVAT14, you can read the name. Seems like a really good idea for a nuclear electric asteroid mining vehicle. Yeah, I think exactly the same as well. I think that would be great for metal mining asteroids, which leads nicely into the second video of the week. That's not it. There it is. And this is metal thrusters plus nuclear reactors, the game changer for Cislunar supply chain. So basically, I'm building on the Neumann drive or the mag drive, but now I'm adding a nuclear reactor for power. So you're swapping out solar power, which is maybe a kilowatt, and putting in 100 kilowatts or a megawatt of power, and thrust scales directly with power. So now you've got a lot more power. You can go further, you can go faster, and you can do a lot more things. So this is, I just make the point that maybe this is a game changer for Cislunar supply chains, or the killer app for space. That is, you can. Well, let's have a look at the plan here. So from low Earth orbit, there's 10,000 tons of materials in from orbital debris, dead satellites, upper spent rocket stages, and half of that is aluminium. 5,000 tons of aluminium just floating in low Earth orbit. And aluminium makes a great propellant for the metal drive. It's 2000 ISP. It's quite low to melt. I think 630 degrees. So if you look at this, and this happened about a week ago in space, you are looking at a furnace in space, and the temperature in this furnace is 1000 degrees, which means it's hot enough to melt aluminium. So we have 5,000 tons of aluminium in space right now, and you have a space furnace that is hot enough to melt aluminium. Combine that with Cislunar Industries that is building an in-space forge that can melt and extrude metals into different shapes, including a metal propellant rod. So they are in, go back to this. So they are, they have a partnership with Neumann Space, to test recycled aluminium as a propellant. And apparently it works great. So you have all the steps needed to bring about this ecosystem. You have the material already in low Earth orbit. You have the space furnace from Space Forge. You have the in-metal foundry from Cislunar Industries. And you have the drive system from Neumann Space and from MagDrive. So you have all the elements to make some kind of cislunar metal ecosystem. So in addition to having metal supply in low Earth orbit, you have it on the moon, and you have it from M-type asteroids. And I do mention in the video, there's at least 3 M-type asteroids that you can get to for about 7.5 kilometers per second. So, you know, some of them are 3 kilometers in diameter, and you can, depending on the launch window, maybe 5.5 kilometers per second to get there. So I mentioned Starship, but I also did check that a Blue Ring, that is the Blue Origin space tug, plus an upgraded upper stage New Glenn, that's with 4 engines, does have enough delta V to get you to these asteroids. It has about 7.5 kilometers per second. Getting back, you'd need to refuel with metal, but you could definitely get to these asteroids using Starship or Blue Ring plus New Glenn. So perhaps in the next 5, 10 years, 10, 15 years, we can start mining metal asteroids and using a metal propulsion drive. And I also do mention the NASA study from 2021 called Nuclear Power Concepts for High Power Electric Propulsion Missions to Mars. And I highlighted this section here using the same, so they have various scenarios. One of them is about a 2 megawatt nuclear power system and electric propulsion thrusters, but without the chemical propulsion. So they propose a hybrid system, but just using the electrical system, so ion thrusters and nuclear reactors. It could perform a pre-crew cargo mission delivering payloads of up to 200 tons to Mars after LEO spiral and 535-day, one-day Mars trip. So basically, it is possible to move hundreds of tons of supplies to Mars using metal drive thrusters and a nuclear reactor. It would have to be a high-end nuclear reactor. It would have to be like a 2 megawatt class reactor. But yes, it does work. You can do it. And I didn't actually show this graphic in the video, but this is just space junk. And as you can see, the amount of space junk is just going up and up and up, and will continue to go up because China and the US and Europe are all launching mega constellations. And definitely in the case of China, their upper stages just stay in space. You know, so you get an extra 5 tons of metal every single time they launch one of their vehicles. So there is that. So this potentially clears up orbital debris, which makes it safer for everyone, and it provides propulsion, and it's a very simple system to use. And I do mention this. Cislunar Supply Hub. This would be Earth Moon Lagrange point 1. It's a sweet spot between Earth and Moon, and basically Starship would refuel at the Cislunar Supply Hub, and then the empty canisters could be crashed on the Moon. So we have Marco Mix 17 Vamos. Let's go. So this system, this is from Firefly Aerospace. Basically, you'd have a servicing hub in space for space tugs and so on. But basically, the empty canisters for refueling would be crashed into the moon. So you then build up more metal on the moon. And I do mention here that it's a lot easier to send metal to the moon than it does to send it from Earth. If you're going to build up a lunar base, you need a lot of construction material, a lot of metal. So if you're sending it from Earth, you need 16 kilometers per second to get it out of the Earth's gravity well, to push it towards the moon, and then to slowly decelerate and land. In total, you're talking about 16 kilometers per second. If you just crash upper stages, rocket upper stages into the moon and then recycle, you only need 3.2 kilometers per second. It's much, much simpler, and the material already exists. So, this is also a concept that you could do. And I talk about orbit recycling. I have a video on that. They just crash this into the moon and then recycle using a metal forge. So I mentioned that. Here's a breakdown of orbital debris by type. So it's 50% aluminium, but you also have copper and titanium and stainless steel. So you have other metals as well. Copper is great for wiring, electronics, and so on. Aluminium is just great in general. It's lightweight and it's strong. And Shane Loader is saying, how pure does a metal have to be used in a metal powered track? It doesn't have to be pure. This is another great advantage. If you're dealing with kerosene, it's got to be RP1. It's got to be rocket grade kerosene. It's got to be ultra pure. Same with xenon, ultra pure propellant. Not the case with metal at all. You can use common grades. That's why I say in the video, $100 per kilo. But you can use some common grades at $10 per kilo. It'll still work. Maybe it's not quite as efficient, but even at $10 a kilo, the drive will work. So another advantage is you don't need it to be pure. Like, can they actually use all the debris? Yeah, they can. All the debris, or would they still be waste to dispose of? As long as it conducts electricity, it will work. The only caveat to that is you don't want a metal with low melting point. So you wouldn't use tin, lithium, gallium, stuff like that. But aluminium is great. It's available in large quantities, and it's already in low Earth orbit. And so I have this here. What's this? Oh yeah, so this is a graphic. I didn't show it in the video, but these are the mega constellations that already exist or will be launched soon. So you obviously got SpaceX with Starlink and Starshield. That's, I don't know, it's 10,000 now. They're cleared to at least 15,000. And so these satellites, most of them work, 99% of them work, but occasionally you do get satellites that stop working for whatever reason. So potentially they could be used, they could be recycled. You've got OneWeb, you've got Amazon with Kuiper, and you've got the EU with the Iris 2. And I mentioned 2 Chinese mega constellations, but apparently it's 10 now, and up to 200,000 satellites from China. So the amount of material in space is just going to go up and up and up. So there'll be no problem with sourcing metal in low Earth orbit. And we have Wayne's World saying afternoon all. Hello, Wayne. And then we have Shane saying, what is the power output of a metal drive compared to xenon ion engine? Well, the thrust is similar, but maybe a bit on the low side. Fuel efficiency can vary, but it's thousands of seconds. And in terms of power output, well, power input is the question. So you'd use solar panels, but I'm suggesting in this video you use a nuclear reactor because the exhaust velocity scales directly with power input. So the more power, the more thrust, the faster you can go, the more missions you can do. So this is why using a nuclear reactor makes a huge amount of sense. And since we're having nuclear reactors in space anyway, NASA's working on that, and it's a high priority. If you combine a nuclear reactor with this drive system, that's the perfect combination. And I do mention K2 Space. They're working on very large satellite buses, the Mega class, which is 3 meters by 3 meters and up to like 20 kilowatts. And then the Giga class, which will be a 15-ton satellite bus, at least 5 meters by 5 meters, graded to up for 100 kilowatts of power. So they're using high power electronics. The whole system is rated for high power, which is what you need for a nuclear reactor. So remove the solar panels, put in a nuclear reactor, use the mag drive, a clustered mag drive, so tens or hundreds of drives all together. And with a nuclear reactor, you can get decent thrust. Newton, 5 newtons, maybe up to 30 newtons of thrust with a 2 megawatt reactor. And with that kind of thrust, it would fire continuously. You can go to Mars. You can provide supplies to the moon, maybe to Mars, and around cislunar space. So that is the idea, that a nuclear powered metal drive is the perfect way for getting around cislunar space, and also for mining M-type asteroids. And David Chung is saying, did you hear about one company, GRU, that is trying to build a lunar hotel? That will be my next video I'm doing next week. Obviously, yeah, I'm very interested in that, and I want to learn about it, research it, and then I'll do a video. So definitely I'm going to cover that next week for sure. Have I covered all the comments? Space debris is yeah, I don't think I brought this up. David Chung is saying space debris is such a massive issue. Glad there are companies trying to deal with it. Yeah, I mean, I mentioned also Astroscale and Clear Space. They both have asteroid debris missions coming up from the UK Space Agency and from the European Space Agency. I know NASA has a mission with, I think, Starfish Space, which is a US space startup. So they're going to try and collect 2 defunct NASA satellites and basically dispose of them. So definitely that technology is on the way. There's quite a few companies working that. You've got space tugs. So all the technology is either it exists or it's already in the technology demonstration phase. So it'll be around in a couple of years. So we have all the parts. We just have to put them together, and we can build a cislunar metal ecosystem. I think I've covered all the comments here, so I'm going to go on to the comments people left about this. So I'll bring that up here, put myself in the corner, and we have, that's Alan Day, 5255. Great job. The name, however, is awful. Cislunar. It sounds like you're making a political statement regarding transgender issues. Anything seen as political can leave a bad taste in people's mouth. And there's a reply from CEO Mac and Cheese. That's what the space beyond geostationary orbit and out to lunar orbit is called by the aerospace industry. Yeah, it's just the name. Cis meaning between. It's the space between Earth and the moon, and a little further, I think, a little further beyond the moon. So this entire region, the Earth-Moon system, is called cislunar space. That's just what people call it. David is saying, there's a company called Chorian that focuses on space domain awareness and orbital debris management as well. Not sure if you've covered them. I'm not aware of Chorian. I think there's quite a few companies working on space domain awareness at the moment. And Shane is saying, it's amazing that this is the first time I've heard of metal drives. Thanks so much for sharing this episode, as it is such a great idea for eliminating space debris. Yeah, it's kind of like it solves 2 problems. It basically solves moving around the cislunar space, and it solves the orbital debris problem. Because the problem with the orbital debris is like, how are you going to pay companies? No one really wants to clear up debris. It costs millions of dollars, and there's no advantage. So you have to make it pay. So turning the orbital debris into fuel or propellant makes a lot of sense. And also pushing it to the moon, recycling it on the moon for lunar-based construction also makes a lot of sense. Rosemary Howell 8694 says, finally, someone articulates my plan. And Ryan Block B5 saying, thanks, highlighting these companies we would never heard of. No problem. And Andrei Popov 6958, it's better to make hybrids. So maybe that's the case, because the problem with these systems is the thrust is very low. So if you want to go to Mars, you've got to break out of Earth orbit. You've got to get into Mars orbit. For that, you kind of need to do high thrust. So perhaps some kind of hybrid system where you've got chemical thrusters and you've also got metal drive. Makes a lot of sense. For instance, the Blue Ring, the space tug from Blue Origin, has both a chemical thruster and an ion drive together. So you've got both systems. And Chris Nisk is saying, do you have any information on the cost of those Neumann drives? No, I don't. But considering how cheap and simple and easy to manufacture they are, my guess is they're quite cheap. But yeah, I don't know. And we have Eval Madra 6223 saying, finally, a workable concept for Cislunar mobility. I like the lunar scrapyard idea. Yeah, it's not my idea. It comes from Orbit Recycling, but yeah, I think it's a great idea. So Poincare Basin seems to me to be the obvious place. It's low scientific interest, very large diameter, low slope, easy to get to, and you'd put your metal foundry on the rim. There's plenty of sunlight, and you'd have rovers come in, cut up and collect the wreckage, go to the metal foundry, melt the metal, cast it into parts, and then you'd have to collect the parts. So I mentioned Starship would do a short hop, or a Mark II from Blue Origin would do a short hop, collect the parts, back to Artemis Base Camp. And over time, you'd build a road network. So that's the idea. And also, if you're going any further than the moon with regularity, as with submarines here on Earth, nuclear power must be in the solution set. I agree. And speaking of submarines, we have decades of experience building and operating small reactors under dynamic conditions. That should translate well to the moon, Mars, and space. Yeah, I mean, the US and other countries have experience of operating nuclear reactors in confined spaces. To me, that technology and that expertise is transferable to space. I would think so anyway. And Shane is saying, I really like the idea of being able to use spent second stages and empty chemical fuel tanks as a source for additional fuel for metal drive engine once chemical thrust is no longer required. Yeah, because you're already in space. Like, it's already there. You just have to go up to it, send it to a metal foundry, and recast it into a metal propellant rod. So it seems doable to me. And CEO Mac and Cheese saying, solar power is cheaper than nuclear material, technical and monetary wise. Unless you are going to say Jupiter and beyond, there is no reason to not use solar power. Well, the reason is fuel efficiency is directly correlated with exhaust velocity. And exhaust velocity scales with power. So the more power you put into the system, the higher the exhaust velocity, and the more fuel efficient. And one extra thing with nuclear electric propulsion is that you can have this intense magnetic field that funnels the plasma in the direction you want, and you can make it very, very hot. And heat is just kinetic energy. It's the particles moving around very, very fast. So your exit velocity, rather than being 10 kilometers per second, is 30 kilometers per second plus. So your ISP goes from 1,500, 2,000, 3,000 to 4,000 to 10,000 ISP. So using a nuclear reactor and a magnetic field as a magnetic nozzle makes a lot of sense and really boosts the fuel efficiency. So that's another advantage. So have I done all the comments here? Rosie Gray 801 is saying, this is a brilliant idea. As a space rocket enthusiast for over 60 years and a keen follower of the genius plans of Robert Zubrin, this concept is just what is needed, both to address the problem of space junk, avoiding Kessler-type collision cascades, and using the material to build orbital facilities, or drop it into an easily accessible spot on the moon. I'm 100% behind this plan. Yeah, it makes sense, right? I think it makes sense. And it's a combination of various things. It's the orbit recycling plan of send debris to the moon and recycle, but also just using it to move around space and adding in the benefit of mining M-type, metal-type asteroids using this system and ferrying supplies to the moon and potentially to Mars if you've got a nuclear reactor as well. And you can make it work. And like I said, there's 10,000 tons of material in space, and that's not going to go down anytime soon. So it makes perfect sense to me. So those are the two videos I've done this week. In terms of what I'm doing next week, as someone said in the comments, Gru is working on a lunar hotel, and I think it's backed by SpaceX and NVIDIA. So I really don't know much. I just saw the press release, so I'm going to look at that for sure. A lunar hotel sounds great, and apparently you can get early bird prices. It's $1 million, so you can book now. So Shane is saying, how big is the metal foundry needed to convert the scrap to usable metal fuel rods? I don't know. Cislunar Industries is working on something, but we already have a furnace in space. This is in space right now. This is from Space Forge. And they're not the only company working on this. So you've got Cislunar Industries, you've got Space Forge. I believe there's other companies as well. I expect Redwire will be working on this kind of thing. So we're going to have furnaces in space for sure. So I guess at first they're quite small. So you're going to make a small fuel rod, but you can make bigger furnaces, right? And then you can make bigger fuel rods. So you can just scale it. So hopefully in the next 3 to 5 years we'll start seeing forges in space. And the metal drive is already in space. So anyway, that is the videos for this week, and I will definitely do the lunar hotel next week and something else that I've not decided. So thank you for joining. Please like and subscribe, and I will see you next week.